Hello everyone, this is a lesson on arithmetic progression. Let's start by taking a look at the definition of an arithmetic progression. An arithmetic progression is a sequence of numbers whereby the difference between any two consecutive numbers is a constant. This constant is called the common difference and is usually denoted by the letter D. As an example, take a look at this arithmetic progression here. We have the numbers 1, 3, 5, 7 and 9, and the first term 1 here is normally denoted by the letter A. Okay, so we have the first term as 1, and the difference between the consecutive numbers, let's take a look at the difference between the first and the second term here, is actually 2. When we take 3, take away 1, you get 2. Again 5 and 3, the difference is a 2. The difference is a 2 here, and the difference is a 2 here. So the difference between any two consecutive number, D, which is the common difference, is 2. So we can say that it meets the criteria for an arithmetic progression. Let's take a look at an exercise. Exercise 1. Given the arithmetic progression, find x. Okay, this is a typical basic question for this topic. So here we have 5, 10, 15, 20, 25 and an x. So you're asked to determine x. We know that the difference between two consecutive numbers in an arithmetic progression is actually D. Right, so if we can determine D, we can determine x. So let's say we put up a formula here. D equals, we take this and take away this number, so we have 25 minus 20, which yields 5. So we know that D is 5. So x is equals 25 plus D, which is 5. So we have 25 plus 5 giving us 30. So x is 30. That's a quite straightforward question. Let's take a look at another exercise. Given an arithmetic progression, find the common difference. We are given two numbers in this arithmetic progression, x plus 2 and x plus 5. The difference D is this term here minus this term, so that will give us x plus 5 minus x plus 2, which means that we will have 3 for D. So the common difference is 3. Take a look at another exercise. Given a sequence, determine whether is it an arithmetic progression. Now, we have seen that for an arithmetic progression, the criteria is that the difference between two consecutive numbers must remain a constant. In this case, with this progression, we can determine the D in this manner. D, let's say we take this term and minus this term, so D is 11 minus 8, which is 3. If we find the difference between these two terms, okay, let's say we call it D1, we are going to get 8 minus 7, which is 1. From here we know that since both of these are not equal, we can say that D is not a constant, and hence this is not an arithmetic progression. A similar exercise. Determine if the below sequence is an arithmetic progression. We have 12, 9, 6 and 3. Let's say we find a difference between these two numbers. So we are going to get D equals 3 minus 6, which gives us minus 3. And D1 equals, this is D1, 6 minus 9 equals minus 3. And then we can have D2, which equals 9 minus 12, which is also minus 3. So here we can see that D is a constant. Okay, it remains a constant, negative 3, throughout the 3 difference between these 4 numbers, and hence this is an arithmetic progression. Now note that D can be positive, negative, or even 0. Like in this case, here we have a negative D, and when we have a D which is 0, it essentially means that the term does not change. You can have something like 10 for a 0. Maybe it's the progression is like this: 10, 10, 10. Let's take a look at the how we can write a formula to represent an arithmetic progression. We know that the first term is A, and the difference between the first term and the subsequent term is D. So we can say that the second term is A plus D. The third term will be A plus 2D, right? Because it's A plus D plus D. So we have A plus 2D. And the fourth term is A plus 3D. Now let's let Tn be the nth term. So Tn would equal A plus n minus 1 D, where n is 1, 2, 3 and so on. Okay, so this is the formula for an arithmetic progression. A being the first term, n being the nth term, and D being the difference. N is actually the number of terms. Let's take a look at an exercise. Given an arithmetic progression as follows: 22, 16, 10. Determine the sixth term. Using this formula, we can determine the sixth term. Now, first what we'll do is we'll indicate those items which is already given. The first term A is 22. D equals the difference between the two consecutive numbers, so we can take 10 minus 16, which is going to yield minus 6. So this is D. Next, we can make use of this formula now that we have A and we have D, and we also know that it's a sixth term. So we can find out T6 equals A is 22 plus n is 6 minus 1, D is minus 6. This gives us 22 plus minus 30, which yields minus 8. So the sixth term is minus 8. Let's take a look at another exercise. Given an arithmetic progression as follows: 5, 10, 15, 60. Find the number of terms in the arithmetic progression. So here, once again, we know that the first term A equals 5. The D is a difference between two consecutive terms, and let's say we take these two terms, 15 minus 10, which gives us 5. So the common difference is D. Using the earlier formula, Tn equals A plus n minus 1 D. Here we know that A is 5 plus, we don't know n, right? Because we want to find out the number of terms. This is what we want to find out. So n minus 1, D is again 5. But we do know that the last term, okay, is 60. So the nth term, this is the nth term, is 60. So this is the nth term, Tn. So from here we can get 55 plus 5n minus 5. So n equals 60 over 5. So n is 12. Now we can verify this answer by using the same formula again. Tn equals A plus n minus 1d. We are looking at the 12th term, so it's actually T12 equals A is 5 plus 12 minus 1, D is again 5. So this yields us 5 plus 55, which is 60. Right? So we know that the number of terms is 60. The number of terms is actually 12, and this is the nth term. Okay, let's take a look at another exercise. Now, given an arithmetic progression which is represented by the following formula, Tn equals 6n plus 33, find the first term and the common difference D. For the first term, it will be 6 times substituting n with 1 plus 33. So the first term is 39. And in order to find the common difference, we would need to know the second term. So T2 would be 6 times 2 plus 33, which is 45. So the common difference D equals T2 minus T1, which is 45 minus 39. So D equals 6. So there you have it. This is the topic on arithmetic progression. This is the first part of the arithmetic progression. It's quite a relatively easy topic, and it's quite apt that we start with this. The second part, section B, will cover the summation of a number of terms, and I'll make another video on that. So check back to the website and in a few days time, and then I'll get it uploaded. So if you have any questions, do drop me an email, or if you try some of your in some of your workbook and you face some problems, or you have some queries, do feel free to drop me an email. and check back to the website often. Bye.